That's always a good question. So there's a channel here called Help Screenshots. So this channel right here is where students post their questions. And if you post it in here, I'll get to it. The distributive property. Yes, I agree. Okay. What are we going to distribute? There's a lot of distributing happening here. Reduction is cosmetic. Resistance is futile. I love that, Jeff, dude. You're great, man. Yeah, you don't know. It's okay. All right. I like to kind of work from like inside out. Okay. So the first thing I see is I see like two chunks of things, right? So I have something. Where's my solid? There we go. Solid. I have something being multiplied by something else, and then all of that is getting raised to a power. So the first thing I'm going to want to do in like my order of like things is let's just multiply these two things together. Okay. So let's see what happens if we were to multiply these together. All right. So let's do 2a to the third b times why solid blocks. I feel like the solid blocks, it kind of puts blinders on things. I think when students see too many numbers and like things, it scares them. So if I just say, hey, it's just block times block, they're like, okay, cool, I know how to multiply things together. You know, it's to see the bigger picture without getting lost in all the details. That's why I do it, Jeff. Yeah. Okay. So how do we think we multiply these two things together? Oh, empty squares? Yeah, but see, the problem with like empty squares is you can still see what's inside, and like I want to get rid of that. Like don't look at don't look at the elephant in the room. Like don't do it. Yeah. That's why I use the blocks. Each term by all numbers in the other bracket. Yeah, okay. So, I mean, the way I like to do this, so when you have like 2a to the third b, that's the same thing as 2 times a to the third times b. And then all this is times 3 times a to the fourth. Now, there's a cool property here in multiplying numbers in that if you have a bunch of numbers being multiplied by each other, you can put them in any order you want, okay? So, you see how like the 2 is over here and the 3 is over here? Instead of having like 2 multiply by all this stuff and then get to the 3, I'm going to take the 3 and put it over here, right? And now, things might look a little bit easier to deal with, right? Let me move the 4 over. Anyways, yeah. Generalized commutativity. Yeah, exactly. That's what we call it. So this 3 times 2 right here, yeah, right away, you know what this is. This is just equal to 6, yeah? All right. Exponents add. Yes, exactly. Yeah, very good job, Cosmic. Yeah. So now I have 6 times a to the third times b times a times 4. And what I like to do, again, is I'm just going to swap places of this b and this a. I'm going to put this over here. I'm going to put this, and then, sorry, keep moving the image. I'm going to put this one over here. All right? Well, yeah, you know, the 4 is still over. Oh, I fucked up, dude. Oh my god. Thank you, Jeff. Oh my god, sorry. I thought there was a 4 here as well. There was not. I don't know why I put the multiply up there. No, thank you, Jeff. Thank you, Jeff. You get a save. Yeah, let's get rid of that. Sorry. This was a to the fourth. Yeah, thank you. Saves for Jeff. Sometimes I get lost in my own sauce. Yeah, it's all good. So, so now this is easier to deal with, right? A to the third times a to the fourth. Whenever you have things being multiplied by each other and they have the same base but different powers, you add the powers. So this is now going to be 6, and then a to the third times a to the fourth is going to be a to the 7th, and then we have times b, okay? And now that's what all of this stuff was. All of this right here was this, okay? But now, let's remember, I still have to square everything that's in this little red square here, right? I got to square all of it, all right? So, that's going to end up being 6 a to the 7th b all squared. Good, Ace. Yeah, exactly. So, what are we going to do next here, 1K? How do I do this? How do I square everything in here? Okay, let me move this away. I just don't need to see it anymore. Yeah. There are actually a couple ways to do this. Exponent rules, yeah. Exponent rules are cool. I like Jeff's way. He says multiply by itself. Yeah, that's nice when this is just like a squared. If this becomes like to the 21st power, not gonna work out. But yeah, exactly. Okay. So what happens is if all of this stuff is being squared, that means I need to individually square each term. Okay. So that's going to end up being 6 squared times a to the 7th squared times b squared. Okay. So, right? Good job. This is going to be 36. What happens here? What happens when I do a to the 7th to the 2nd? What's that? It's kind of weird, right? What's that? What's that 1K? A to the power of 9. Close. Yes, yes. So this is, so whenever you're doing power to a power, you got to multiply them. So this is actually a to the 14th. If you want to see why that is, let me show you why. Because, like, you know, you can believe exponent rules all day, but, like, you know, that makes sense unless it actually, like, works. So watch this. So a to the 7th to the 2nd, right? That's the same thing as something squared. And I know something squared, right, is the same thing as something times something. Right? This is equivalent. If I have something squared, it's the same as it being multiplied by itself. Okay. So, in that case, that's a to the 7th times a to the 7th. Which here you should recognize, right? Same base being multiplied, different exponents. I'm going to add the exponents. So this becomes a to the 7 plus 7, which is equal to a to the 14th. Okay? And you see how that's a to the 2 times 7? See how this equals a to the 2 times 7? Yeah, that's why. Thanks, Cosmic. Yeah, so if you ever don't... Again, I used to do this all the time, bro. Like, when I was in school, I used to forget, like, which fucking exponent rule it was, right? I'm like, is it the adding one? Is it the multiplying one? Like, which one is it, right? If you ever get confused, just use placeholders. Use, like, 3 and 2. Don't use 2 and 2. I've explained why 2 is a bad number. It's because, like, 2 squared equals 2 times 2, which also equals 2 plus 2. So, like, the multiplication rule, the exponent rule, and the adding rule all get you 4. So that's not good. Try to not use 2 with things. But if you wanted, like, an explanation for it, right? You could think, okay, let's see if I had x to the 2nd times x to the 3rd, right? And you're like, wait a minute, is this like x to the 2 plus 3 or x to the 2 times 3, right? So is it x to the 5th or x to the 6th? Let's say you just forgot the rule. You can create what's called like a test case. So you create like an example problem and you see which way it goes. So in this case, x squared is the same thing, right, as x times x, and x cubed is the same thing as x times x times x, right? X times itself 3 times. So when I multiply these things together, now I have x times x times x times x times x. So that's x to the 5th. So that was x multiplying by itself 5 times. So I see that, okay, cool, look. This rule, right, when I do x to the a times x to the b, it ends up being this one. It's x to the a plus b. Just a way for you to test it, 1K. Like, if you forget on the test, do like an example problem real quick and then just see which one it should be. That's, you know, the explanation here is how I was like, okay, look, it's a, b. It ends up being a plus a times b, right? This is equal to a times b because it's a to the 14th. Okay. Anyways, so yeah, so a to the 14th, and then this just becomes times b squared, and you are done. That's the answer. Good job. Nice job, 1K. 15 bond coins. Getting up there, dude. Nice. Good stuff. Okay, here. Let me do... okay, I love your question with the bearing. I will do that. Let me do aces real quick. This is not a bad one, ace. I know this one. I feel like I've done this question on a video. It's like elevators, right? Yeah, elevators. Oh, no. Oh, these are cable forces. Oh, okay, never mind. Okay. Yeah, never mind. So I was thinking about apparent weight. Apparent weight is something that happens. Okay. An elevator and its contents have a combined mass of 6,000 kilograms. It is suspended by a single cable. Assume 4 sig figs. Okay, who cares? Draw free body diagram on the elevator. Okay, cool. Free body diagrams are great. We call this like FBD. Why do they ask E? Because some students don't understand what the forces of something are when it's falling. Yeah. Okay, cool. So, you have two forces. So actually, the first force you should always draw, Ace, like no matter what, as long as we're on Earth, is just always draw the force of gravity. So we can say this is going to be the force of gravity, which is equal to M times G, which in this case is 6,000 times 9.8. Okay? And then the other force we have is going to be the force of the tension in the rope, which we can call Ft. Okay? And that's going to be equal to some, like, mystery number, right? We're going to end up, like, solving for this. I mean, it just scares me. Oh, you have the cable snap? Yeah. It's like, what if you just died? Okay. Okay, it says, what force must the cable exert on the elevator when it is at rest? Okay. So, to do this, we use Newton's laws, which in order to use Newton's laws, first you got to write out what all the forces are. And then once you got all the forces, you write out, I think it's Newton's second law, which says that sigma, which means adding up. So if you add up the sum of all the forces, this should be equal to the mass times the acceleration of the object. Okay? Oh, you're good, Ace. Lamau. Okay. Anyways, yeah, we're doing your elevator question here real quick. Minor issue. C ends with seconds squared and D ends with seconds. It's probably a typo. Yeah, my guess is this is a typo because they want it, because the whole design of these two parts of these questions, Jeff, is to like show how the sign changes. I think so. Yeah. Yeah, otherwise, yeah, we don't know about the acceleration. Yeah, I agree so. Yeah. So, again, Ace, force diagram, right? Just always draw the thing. Draw the forces acting on it. I say always draw the force of gravity. Gravity always points straight down. So gravity's always pulling things down. That's a force. And then it has a cable that's keeping it up. And so that's going to exert a tension. So that's a force pulling it up. Okay? And then what we're going to use is Newton's laws here to add up the forces. And this is where it becomes tricky with the sign for things, okay? So what I'm going to do, I always like to do this. I like saying, okay, this direction is up, is positive. This direction is negative, okay? So when I'm adding my forces, force of tension is going to be positive. I'm going to say, cool, force of tension. That's a positive thing, right? You don't have to write the positive there. Then technically we're adding, sum here means add. I'm going to add the force of gravity, which is negative. So I'm going to say plus negative Fg. And plus negative is the same thing as minus. Okay. The sign convention is important. This is the number one thing that like gets screwed up in physics all the time. Is knowing which one's positive, which one's negative. And a lot of times you'll just try to like figure it out at the end. But general question, what law would apply to an apple falling on Newton's head after time has passed, no external force has been talked about? Like which one of Newton's law? I gotta figure out which ones are which. An object at rest stays at rest. An object in motion stays in motion. Okay, cool. The acceleration of an object is proportional to the net force acting on it and inversely proportional. There's no external forces. So it's definitely not the third one. That's action and reaction. You know, it's a toss-up between 1 and 2. Yeah, it's either 1 or 2. It's definitely not 3. Yeah, probably 2. Oh, after no external is for. Okay, yeah. So this only says like unless the first law refers to when an external force is present. So because there's no external force present, I mean technically gravity is always an external force. Yeah, but that's my issue is that gravity is an external force and gravity is always acting. Gravity's always there. Gravity's that just lurking, you know, just that camping sniper or whatnot. It's just like I'm always here. Watch out. Anyways, okay, so Ft minus Fg, it's equal, and then that's going to equal to the mass times acceleration. All right, so when it's at rest, when something is at rest, the acceleration is 0. This is going to go to 0. And so when that happens, okay, now you have that, okay, Ft minus Fg is 0, so you can move Fg the other side, and you just get that Ft is equal to Fg. This is when A is equal to 0. Okay. Which you can solve for. Because here, I'm going to be lazy and just set this equal to 10. I know it's kind of wrong sometimes, but I don't want to bust out my calculator for the extra 0.2. So, yeah, this just tells you that Ft is equal to 60,000 newtons. Because the force of gravity here, right, this is going to be 60,000. Okay. Part 1, or part 2, I guess. What force, if it is moving upwards at 2 meters per second? Okay, if it's moving upwards, so that means going this direction. A here is going to be a positive 2. That's what changes. M is still the same mass, right? That's 60,000. Okay. Or 6,000, sorry, not 60,000. Okay. So now, and so here's the cool thing. Force of gravity always stays the same. No matter how this thing is accelerating, it doesn't matter if it's accelerating right up or accelerating down. The force of gravity is always the same. So what you end up getting here is that like F of t minus 60,000 is equal to 6,000 times 2, okay? This is going to end up being 12,000. So that means this must be 72,000. Right? Because if I add 60,000 over to here, I'm going to get 72,000. So, yeah. So, in that case, the tension is going to be 72,000 when it's moving upwards. Yeah, so this will be 72,000. This is going to be 60,000. And then what's cool, they say if it's moving downwards, and they should be saying that it's accelerating downwards. That's the key thing here, and Jeff pointed this out. If the units here are meters per second squared, this is an acceleration. If it's just meters per second, it's a velocity. I believe this is a typo. Like, this should be squared. Because I believe the intent of this teaching is to show the difference in the directions of acceleration. So, for the next part where it's moving downwards, this is now negative 2. Okay, so that gets you negative 12,000. And so now if you add this, 60,000 to negative 12,000, that's going to get you a lower number than 60,000. That's going to get you 48,000. Okay? So this ends up being 48,000. So this is kind of the cool thing. The tension in the rope changes based on whether it's coming up accelerating or it's going down accelerating. And what you're eventually going to get to, aced here, is having this be, instead of a tension, you're going to end up talking about a person who's standing on a scale. And we're going to talk about what's called the normal force on the person. And then that is related to how heavy you feel. So this is, I don't know how many elevators you guys have ridden in, but if you ride on an elevator, you'll probably notice you feel like heavier or lighter at certain points while the elevator is going up and down, especially if it's like a really crazy elevator, like one of those like massive like 80-story ones or something. That has to do with this, which is related to what we're showing here, which is that based on the acceleration of the elevator, the force here, the tension, is changing. So it goes from being high to low. Yeah, okay, cool. And then it says, if the cable is snapped, what is the elevator's motion as it falls? Yeah, it just fucking falls. Like, goodbye. Then there's no force of tension. There's just force of gravity. And the acceleration equals the force of gravity. Because look here. So if I do this, right? Tension is gone. And then you're just left with mass times acceleration. Right? You remember that this was just negative m times g is equal to like m times a. So in that case, gravity is your acceleration downwards. Yeah. Yeah. You can post your quiz question, but yeah, good job.
Well done.
Yeah. Ace brings up a good question. You're asking, is normal force usually equal to gravity force? It is, unless the object is accelerating in the up or down direction. So, in the case of the elevator, if someone is standing in an elevator, okay, and the elevator is not accelerating, okay, in that case, yes, the force normal will be equal to the force gravity because the person is not accelerating. However, if this starts accelerating up, okay, then what happens is this normal force has to go up because you still need the sum of the forces. You still need this minus this to equal the m times a for the whole thing. I did do a TikTok video on this. I know I've done one of these. One sec. I've done the elevator. I know I have. Where is it? There we go. This one. Yeah. So, and this is actually one of the good ones I did.
Some sort of problem involving an elevator.
So this involves like, yeah, the person on an elevator, and it's asking about how heavy they feel on the elevator based on whether the
normal force is what
it's going up or down. So,
and this force is directly related to how
go
heavy
check
a
that
person
out.
feels, or their apparent weight. Let's consider the first case, where a
That's an old school meme
70-kilogram
there.
person is standing on a scale in an elevator.
But yeah, I go over like how the forces work and like why one has to be bigger than the other. This was actually kind of a cool video I did, but anyways, check that out if you need help. What's up? Thanks for all the follows today, guys. Blue Spider Monkey and Morning Star Option. Nice. Okay. All right, here's the text. Okay, yeah. So this question is literally, it's literally what I just showed you. It's literally this. How you do the question is here. It's in here. I've done this one. I'll do it real quick just because it's easy. Okay, so you have 50 kilograms, right? You have 50 times 9.8 pulling down, and then you have the normal force pulling up. Is this where all the nerds hang out? I'm here to collect lunch money. Bro, do people even have lunch money anymore at school? It's probably all like an account or something, or some like card or Apple Pay. Like, do you all even use cash at the lunchroom anymore? Like, I used to have to go up with like $3 and like buy a slice of pizza or something. Yeah. But yeah, all the nerds hang out. I'm a nerd. Be nice to nerds. Nerds will be your boss. I'm here to learn science and math. All right, cool, man. Well, we're learning physics right now. If you have a question about science or math, you can always join our Discord, and then you can like drop questions in on. There's a whole channel I have for this. It's called like help screenshots, and then so students post the screenshots of questions they need help with, and I'll just do them. It helps everyone. Everyone like kind of learns. It's fun. I always brought lunch. Call me spoiled. Yeah, no, I always brought lunch too. My family was fucking poor. Like my mom was like, "You're not. There's no money for you to go buy your lunch at school." I used to get jealous because all the kids would get like Chick-fil-A or like we had Pizza Hut at our school. And I was like, "Oh man, here I am eating like peanut butter and jelly sandwiches." I have 5 sisters though, so like it was difficult for my mom to justify us all buying our lunch. It would be a lot of money. Okay, cool. Acceleration is this way. And what do we say this was? 2.3 meters per second squared. Thank you, dude. Yeah, let's get on the lots of money train. I'm down with that. More money means more money for you guys. I stopped bringing lunch. Extreme brokenness. Yeah, I mean, if you're really broke, I think they legally have to give you lunch for free. I think there's like there's some like law or something. I don't know. Okay, so here we got sum of forces. So that's gonna be Fn minus what's that? That's gonna be 49. Yeah, that's 49. Because that's what this is. This is equal to 49. No, 490. Forgot a 0. There we go. Almost an oopsies. Jeff was like, almost got you, dude. And then this has to equal to the mass. So that's going to be equal to 50 times negative 2.3. Jeff is always watching. Yeah, Jeff is always watching, dude. He's like gravity. Jeff, can I? Are you gravity, man? Is gravity in the room with us right now? Gravity's always in the room with us, even when you're not streaming. That's kind of creepy. Okay. Anyways, we can do some numbers here. So 50 times 2.3. That's gonna get me 115. So now I have that Fn minus 490 is equal to 115. What else are we gonna do here? So now I'm gonna add 490 to both sides. Sorry, add. There you go. Add 490, and then we're gonna get that Fn is let's see, plus 490 is equal to 605 newtons. Okay, but that's not done. So like, if you tell someone like, yo, bro, I weigh like 600 newtons, someone's like, I don't know what that means, right? So here's the quick conversion. Anytime you have like a weight in newtons and they want like the apparent weight, because this is how much you feel like you weigh. So normally you feel like 490, you feel like 490 newtons, but now you feel like 605. But that's not a very useful number. So, you want to wait. If the roller coaster's going down, wouldn't you feel? Did I do something wrong here? Oh, I did. Jeff, thank you, Jeff. This is a negative. Jeff gets another save today. Thank you, Jeff. Double saves. Okay, yeah, sorry. It's not 605 because I forgot the minus sign on this. Dumb. No. I'm really disappointed at myself. It happens sometimes. But yeah, you know, it's okay. So this is negative 115 plus 490. It's 375. Okay, cool. Yeah, so you weigh less. You were scared for a second? Yeah, it's okay. I scare for my own sanity too sometimes. Okay. So you usually weigh 490. Now you weigh 375, but the weight you kind of want in kilograms, I would say like the apparent mass. It's kind of like what I like to think. So the way to do that is just to divide this number by 9.8. Okay. Because, right, mass times gravity would now be equal to 375. So I'm like, okay, well, what mass gives me 375 newtons? So I can just divide by g on both sides. Okay. And so if we divide that by 9.8, you get that now you feel like you weigh 38.27 kilograms. Okay. That's kind of what I would say for like apparent weight. Because, you know, originally you were 50. Now you're 38.27. You feel lighter. Yeah. Anyways. Cool. Good question. I like that. It's a fun one. That comes up a lot. The eventual evolution of this question, by the way, is going to be when you have roller coasters. And now you're going to have to take into effect what's called like centripetal acceleration. This is what's coming up next. In terms of like apparent weight and stuff. Let me check how our YouTube's doing. Where's Sensation? I miss Sensation. Where's Sensation? Okay, we just said, yeah, no chat. Okay, we're good. Nice. Okay, cool. Yeah, roller coaster is the final performance track. Check. Yeah. That always comes up next. It really does. Okay, cool. Let's pull up OK's question. What's up, Equity? Yeah, Equity, for some reason, your image is like not displaying on Discord. Like I click this and it doesn't show. I don't know. Something's weird with my Discord, I think. Or the image is weird. All right, let's see. Is okay in the chat? Is okay in the chat with us? I could try to open it in the browser. That's a good idea. Oh yeah, okay, that does open. Oh, so Discord's just having issues rendering it. Oh, that's whack. What up? All right, okay, here. Let me do yours and then I'll do equities. I object to this question because Earth is spherical. Discord do be whack sometimes, dude. Yeah. It's okay. All right, a plane is traveling. I had to like I had a stroke for a second. It is, I guess it is double L's for traveling, right? It looked kind of strange for a second. Man, 800 miles per hour. Okay, good. Well, no, now we're dealing with things in minutes. And the units here just like bug me out, dude. But okay. So 800 miles per hour for 1 hour and 30 minutes. It has this bearing. Oh, remember we talked about this? So, south 79 degrees east means 79 degrees east of south. It's weird. Bearing is such a weird thing. I really don't like bearing at all. That we should just call like north 0 degrees and then, or no, we should just call east 0 degrees and then just let everyone figure it out from there. Okay. The plane then turns and heads due west at a reduced speed of 600 miles per hour for 2 hours and 10 minutes. What bearing should they take to return to the airport? Oh, okay. This is a classic question. This comes up all the time. I've done this one a lot. It's actually kind of cool, though. Okay. I like to draw things like this first. We may have to use law of sines and law of cosines for this, I think. Are you doing law of sines yet? Okay. Because that's usually where this comes from. Also, I'm going to convert. Is it just vector addition? Yes. Yeah, you can do it with vectors. Yeah, you can. There's two. So, yeah, this is a good question. Are you allowed to use vectors? Because sometimes students take this, they're asked this question and they haven't learned vectors yet. So, the easiest way, yes, is to use, to decompose this into components and then use vectors. Yeah, or exactly right. So if you haven't done vectors, I can't show you the easy way with vectors. I gotta show you the hard way, which is with sine and cosine. Yeah, exactly. Yeah, they don't know what vectors is. Yeah, this comes up all the time. Like this question gets asked, and there's an easy way to do it if you know how to use vectors. If you don't, you have to do the hard way. Which I'm sorry, but we'll do it. Okay. So I'm gonna get like some. This question does assume that the Earth is flat. Yes, I know, Jeff. There are people there that believe that. All right, let's get all the distances first, okay? So I know, right, that distance is equal, right, to speed times time, okay? Here we say that this thing is traveling at 800, and we're going to say miles per hour. So then when we multiply by the amount of time that it goes, that also has to be in hours, by the way. This is 1 hour and 30 minutes, which we know is 1.5 hours. So I'm going to say 1.5 hours, okay? Because I need hours to cancel. So that's going to get me 1,200 miles. Okay, so that's the first leg. That's this, okay? And then so let's draw that. So 79. So south 79 degrees east is the same thing as 79 degrees east of south. It's weird, but that's the way I like to remember it. So if I was going south, right, I would be going this way. But I'm going 79 degrees east of south. So east is pointing this way, right? East is this way. So I'm going to go 79 degrees east of south. So that's going to be like this, kind of. Yeah, right? There we go. Okay, cool. Let's move it a little bit. Okay. And then we're going to say that this is 79 degrees. Okay. And then also that the length of this is 1,200. Okay. Now they say it turns and heads due west at a reduced speed of 600 for 2 hours and 10 minutes. Okay, so let's get the next. So this was, let's say this was this distance, for instance. Okay, so now let's do this one. Oh, I see why this is triangles. You know why this is triangles, Jeff? Because the return thing is only due west. If it was at any other angle, I would have to start using law of sines and cosines for this. But because it goes just west, this is a right triangle. Yeah. That's the key thing here. It's this part. Yeah. Jeff and I are seeing this from like the educator point of view, and we're just like, how are they designing this question? Okay, same thing here. So this is going to be 600 miles per hour. So let's do the D. And that's times, this is 2 hours and 10 minutes, okay? So this is, I got to figure out how many hours is 2 hours and 10 minutes. So I know that's 2 plus 10 over 60, right? Because this is 10 minutes out of 60 minutes in an hour, okay? So pull out the calculator on that. So 2 plus 1 over 6, that's 2.16 repeating, okay? 2.16 repeating. All right. So now we're going to go here. You're actually right. We might actually. I hope we don't. We're going to see. Actually, I don't know if we can check that, actually. Okay, we're gonna have to see this, Jeff. Okay. Yeah, you're right. Maybe we don't. Okay, so that'll cancel. And then we're going to multiply that by 600. And that's going to equal to 1,300 miles. Wow, what a nice number. That's really nice of your teacher. Yeah. Like, I say, like, sometimes teachers are nice, sometimes they're not. Okay. But you're right, Jeff. This does overshoot. That's unfortunate. 1,200 would have been nicer. Yeah, I agree. Okay. So, what I do when I draw that, like, something is going somewhere else, I draw a new coordinate axis. Okay. So I'm going to draw a new coordinate axis here. Or I can just copy. Let's just copy this one. Okay. So it's going to go here. And then it's going to come directly due west. So that's going to be in this direction. And it's going to do that for 1,300. Okay. So what they eventually want us to figure out, right, is what bearing, right? So what do I have to do here to return back to the airport? So on the test, we do not have a calculator. Okay. Okay, if you did, well, okay. You should be able to do, I don't think it's 5, 12, 13. Is it? You think this is 5? Maybe. Oh, that's whack. You think this is the hypotenuse? It could be. But I don't think a 5, 12, 13 has... Oh. Maybe. Maybe. We'll see. We'll see. We'll see if this works out. That's actually kind of cool if it does. It depends on this angle, Jeff, right? Doesn't it? Because right now you have none of the angles. I don't. Okay, so... okay, you're asking, like, if I don't have a calculator. Okay, so you should be able to do this in your head. 800 times 1.5. If you don't... I mean, you can do it the long way, right? You could literally set up this. Or you can be clever and realize that this is the same thing as 8 times 1.5. Yeah, which is 12, and then just add a couple zeros. Okay. This might be a little tricky, right? So this is 2 plus 10 over 60. So this is 2 and 1/6, right? Which is equal to 13 over 6. And when I multiply 13 over 6 by 600, right? These are going to cancel to just get me 1,300. I think you need to drop an altitude and I need to drop my attitude. Yeah, that's too funny. Okay, so does that make sense okay? How I could get this by hand too if I wanted to? Okay. Okay. But now we need to get from here to here, okay? So that's what this needs to be. So now we need this. I don't think we're going to get it without a calculator. I think you technically need a calculator for this. Yeah. I mean, maybe not. Let's see. What's up, Sam? Sam always with the chugs. Thank you, Sam. I know Sam's here because Sam makes me drink water. Oh, what did I do to my screen? Oh, look at that. What? Wait. How's it? What? Excuse me? Wait, how did that happen? It just makes my whole like Discord, my whole OBS mess up. Wow, that's crazy. Yeah, you can check your answer key to see how your teacher does it. I think you need a calculator for this. I think we are going to need a calculator. I'm trying to see if there's a way to do this without a calculator. I don't think so. But okay. So what I do know, right, is if this comes all the way down, that now I have a right triangle, right? And if this is 79 degrees, what does this have to be? Right? Right triangle, 79. This has to be something. That angle has to be 11 degrees, right? Yeah, so this got to be 11 degrees. Right? Is that right? Is that right, Jeff? I feel like that's right. Yeah? Okay, cool. Trying to do this without a calculator. I want to use law of sines. I really do. Except I don't know this angle though, Jeff. Right? I kind of want that one too, don't I? And I want this one. I want them all. Yeah, right? Is there a bigger... I mean, this adds up to 90, right? Which means this plus this has to add up to 90. Yeah, no, you can break it up into this piece and this piece, for sure. And then I could get this component, I could get this component, and then, and then what? Well, angle, side. Well, no. Yes. Angle, side. Oh, I know what I can do. Angle, side, angle, side. Right, okay. Then I can get the side, and once I have the side, I can get the angle. Yeah, that's what I can do. I'm curious if, okay, so my teacher definitely used a calculator, but he said on the test they would make it so your answer is what you would put in the calculator. Interesting. Okay. Yeah, I mean, we can solve it symbolically if we want to. I mean, we should just get numbers, but... Yeah, okay. Let's see. Did they use law of sines? Okay. Did they do this? Did they say, like, sine of 11 degrees over x is equal to, I don't know, like, sine of 79 degrees over 1300 minus something? Did they use this? I want to know, like, what things I'm allowed to use on your question. I know how I would solve it. Well, Jeff and I would have just written vectors from the beginning, but... I believe you have to use law of sines for this one. Unless... Jeff, do you see a way? Jeff would have projected this to spherical coordinates. Yes, he would have, Jeff. Newton's 3 laws. No. They what? They did it differently, I think. You want to send it to me? You want to? Can you post a screenshot of the solution just so I can see what I'm allowed to use? It's okay. Yeah. If you send the solution to me, I will understand it. It'll take me like 2 seconds. Like I'll understand real quickly what he's doing, and I can explain it to you. Oh, it's paused. Oh, yeah. Can you post post the screenshot of the solution in the same screenshot channel, and then I'll let you know. I'll let you know what he's doing, because I don't want to go too far forward. Okay, cool. Thanks. Perfect. All right, Jeff. Let's see what this guy's doing. Oh, brother, brother. What? Why is he using tangent? This motherfucker, dude. Yeah. Yeah, he's using vectors. He's cheating. He's like using vectors, but not telling you that he's using vectors. What a bitch.
Hello.
Yeah, what's up, Ramton?
How you doing?
How's it going, dude? Yeah, I was doing like a triangle problem with one of the students here, and I always just want to like do things in vectors, but then the student's like, oh, but we haven't learned vectors yet, and I'm like, okay, but what am I allowed to use then? Is this vector calculus? No, this is not vector calculus. This is just vectors. Yeah, vector calculus deals with calculus in many different variables. Vector is just a word for something that is an arrow that has like a direction and a length. That's all a vector is. Yeah. So let me see. How's he doing this? 1300 minus x over y. Yeah. What a cheeky man. But okay, here. I'll show you how we're going to do it. Okay. Uh-huh. Okay. So, first thing we're going to do here, okay, is I'm going to draw an altitude. Like Jeff was saying, we got to work with our attitude and our altitude here. So we're going to do this. We're going to pull this down. Do Cartesian coordinates count? Yeah, maybe. Okay. So, this right here, okay, makes kind of like a right triangle, all right? Does that make sense okay so far? And let's call that something. Let's call that y. I'm just going to call it y. Okay, so that, right, is equal to 1200 sine of 11 degrees. Do you understand why that is? Or would you like for me to draw out the trig identity? I can draw it out. Yeah, totally cool, man. All good. All right. So, we have triangle, right? We have 11 degrees. I have that this is 1200. The sine of 11 degrees is equal to the opposite over the hypotenuse, okay? This is the opposite side. This is the hypotenuse. So we say this is equal to opposite all over 1200. Okay. So then I'm going to multiply both sides by 1200. That's going to go away. And I get that 1200 sine of 11 degrees is equal to the opposite. After you do the 1200, your position is... Yeah, we're not going to say position, Jeff. We're going to have to say, like, length. It's okay. Okay, so that's why this is it. Oh, does it make sense? Yeah, cool. All right. Nice. Okay, cool. All right, I'm going to... Well, I will move this somewhere else because I want you to be able to download this at the end of the day. Just see everything. So here we're gonna do that. Okay, cool. Oh, I'm missing this. One sec. Okay. So this is 1200 sine of 11 degrees. It is not a 5, 12, 13. I agree it's not. I predicted it wasn't anyways. Okay, cool. So that's what that is. All right. Now that I know what that is, I can also figure out I want to say I'm running out of colors. Let's figure out what this is. Okay? So, okay, I'm going to figure out the length from here to here. Does that... I'm going to show you why we're going to do that, okay? All right. That length is going to be equal to 1200 cosine of 11 degrees. Do you understand why that is? Do you understand why this length in this triangle is 1200 cosine of 11 degrees? Okay, I'll try not to fuck it up, Jeff. Thank you. Okay, cool. All right. So if that's 1200 cosine of 11 degrees, because at the end of the day, what we're trying to figure out here, okay, it's always good to like keep your eye on the prize. Like, what are we trying to do? I'm trying to figure out this angle, right? If I can get this angle, that's the bearing that I need to do to return home, right? Yeah, cosine is adjacent of hypotenuse, yeah. So the reason, and in order to get the things for this triangle, okay, I need this side and I need this side. Because once I have those two sides, I'll be able to find the angle. That's the big picture. That's where we're going, okay? So if this whole thing here is 1200 cosine of 11 degrees, what is this distance going to be? This distance right here. One sec, let me drop. What is this going to be? Let's remember that the whole thing here, this whole thing here is 1300, right? This thing right here is 1200 cosine of 11 degrees. And then I'm trying to get this little blue part right here. I'm trying to get this. I love all the colors I can do. This actually looks like some like some LGBTQ like flag I just drew. Yes, correct. Yeah, right. It's the right colors, Rampton, isn't it?
Yeah, I mean, now that you pointed it out.
No, I'm like, oh, I created a new LGBTQ flag. Yes. Okay. Yes. Good. It's 1300 minus. Can you paint with all the colors of the wind? Yeah. Calm down, Pocahontas. Wait, am I allowed to say that too? Isn't that like a derogatory term now? I don't know.
What's a derogatory term?
I think Pocahontas. I think Trump used it against Elizabeth Warren when they were in the presidential debates or something way back in like 2016. He used to call her Pocahontas because she did claim on her Harvard application that she was like 1/32nd Native American or something.
Okay, that's a stretch, but
it is. But I think in the U.S., in order to qualify for scholarships, in order to qualify that you are Native American, I think it's 1/64th. So like she was good. Yeah. Yeah. Anyways, it's
like that's 8 generations ago.
Yes. Well, I mean, technically we've been like pillaging this land for at least 8 generations, right?
No, I know. I'm just saying that's a stretch because like if you want to go that far back, everyone's gonna find.
Yeah.
It just seems like a low bar to put. Like people are gonna be like, "Oh, I'm indigenous. I'm 1/64th."
Oh, Jeff says it's 6 generations. He said, "Yeah, 2 to the 6th is 64 is 6 generations."
Or sorry, yeah, 2 to the 6, 6 generations. But yeah, I still feel like 6 generations is a stretch.
I know.
It should be like 2 or 3.
That's why Trump was making fun of it. He was making fun of it. He was just like, that's why he
I
called
also
it
think it's
Pocahontas.
just unfair for the people who are actually like.
Who are actually, yeah, like half Indian or something. Yeah. Or
Yeah,
half. It's like, yeah. The
That's
problem is like
that's
those people don't even have a chance because they live on reservations, which are like absolute shitholes in the United States. Like it's so bad.
Yeah, unfortunately.
Yeah. Okay. All right. Cool. All right. So yeah, you're correct. So yes. So this little small bit here is 1300 minus 1200 cosine 11 degrees. So now I have a new triangle, right? And I can figure out this. We can figure out this angle. I'm gonna show you how that works. Okay. Because now, man, I wish I could do like a dashed box, but okay. Let's. Yeah. So this, we're gonna draw it for you here, right? Okay. Look. This is something going up this way. It's this amount, 1300 minus 1200 cosine of 11 degrees. And it's this amount, which is 1200 sine of 11 degrees. This is probably one of the prettier questions I've done, like artwork-wise. I kind of like this one. Okay. So, okay. Do you see how I now took this triangle? Like this small triangle we had, right? Like this triangle. And I'm redrawing it down here. Yeah, you do? Cool. All right. So then... What's up, Pen? How's it going, dog? Good to see you, bro. Penn Center says, what's up? Oh, Penn, I was going to ask you real quick, while you're here. In the, what is it, the calendar we have? Was it the weekly streamer calendar? Oh, it's fixed. Okay. Yeah, it was doing like some, not the calendar. So, like, I think anytime someone updated something, it would make an announcement here. I assume you're fiddling with it because I liked when it showed the full schedule, but then it was replacing that anytime like someone updated a calendar event. Pencer, I wish to once again thank you for your great gift. I was here to stalk Dr. Gold right from the moment he started. Yeah. Yeah, actually, for those, sorry, quick announcement. I'm going to make a server-wide announcement for this. So Penn Center has done some awesome work here, kind of trying to unite a lot of what the math streamers on Twitch are. Because some of you guys ask me, like, hey, I can't view your stream at this time. Are there any other people I can work with to get help? And so here in the weekly streamers channel, weekly streamer schedule, there's an update. There's a big, massive Google Calendar that every week will show every single math stream that's happening. So if, for instance, you can't make one of our streams during whatever time, you can look up any of these other awesome streamers like, Zach, Eat of the 2i Pie, Penn Center, right? Of course, here, he's doing physics and some days. And you can figure out when other people are doing stuff. No, I like the announcements. That's fine. Yeah, the announcement is... I feel like I don't need this. I feel like this is what I like. I like the calendar. I like the... Can you make it, Penn Center, so that this calendar shows, and then maybe that it updates... Like, if someone changes their time, I'd like it to update, I guess. It should still update automatically. Awesome, cool. Yes, thank you, Penn. This is great. I would also ask, do you want an announcement for any updates? No. No, I think that's okay. Because I think what I'll always do, I'll just tell people, just go to the schedule channel and just check, like, who's streaming at what time. And, yeah, thanks, man. Yeah, awesome. And people can sign up for things, right? So if you click on one of these events, you can go to... Oh, Eric has his own Discord. Oh, that's his Twitch. I felt like there was an... oh, that's a calendar event. Sometimes when you click on these things, I thought it went... Or maybe that's only in your server. It goes to the actual event page. What's up, Whipping Cream? I'll do that right. Meow. Thank you. Okay. All right. What's up, Whipping? Yeah, no, it's okay. Don't do events, please. Yeah, because then it would be just flooded with things. Actually, wait a minute. What? Where is that coming from? Wait, what? Excuse me. Wait, one sec. There's another camera somewhere. Where's this other camera coming from? It's showing things. One sec. I gotta find it. Webcam. One sec. It's on my Discord somewhere. No, Twitch summary. Webcam 920. One sec. Where is it? Oh, I think it's this one. One sec. I put that over here. Aha. Okay, I got it. I know what's going wrong. This webcam is massive, and it needs to go over here. Okay, cool. Now it's fixed. Hey, Zach. Oh wow! Oh wow! The gold kappa, dude. The golden kappa, dude. How did you unlock that? That's a great one. What's up, Zach? Yeah, good to see you, dude. Zach's another one of our awesome streamers here. I should shout you guys out. One second. Let me do shout outs. So yeah, shout outs to, and then okay, we're gonna finish your question. We're almost there, dude. We're so close. Shout out to Penn Center. Penn Center is an awesome math friend. And then shout out to Eat2iPie. Oh, I gotta wait another minute before I can give another shout out, but I will shout you out. Yes. You're streaming at 4 p.m. tomorrow, and Zach is streaming at 6:30. Do you plan to go for 2.5 hours? So that's what I like. I like that now I can see the grand scheme of like when people are streaming. So one second, let me pull it. I gotta hide my actual calendar so they don't see everything I'm doing.
There's like multiple. Oh, all right. Yeah. Never mind. You beat me to it.
Yeah.
I was literally gonna say that we should put this on a.
It is. It's on a Google. Sheet. It's on a Google Calendar, and then he has a bot that then will post this in servers so that it shows like all the times.
Oh, okay. Wait, do you think? Can you link this to me?
Yeah.
Oh wait, is this every math streamer or is it just one person?
It's everyone that Penn Center has like gathered together in his conglomeration of Math Federation, whatever we're gonna call it or something. I don't know. There's a lot of debate over like what the name of this thing would be.
If we get it big enough, maybe we can just like have like a specific like category like dedicated to it.
Yes, yeah,
like,
it would be
a long-term goal. Hopefully,
that is the long-term goal is that there's so many viewers and so many whatever that, for instance, certain times are physics, certain times are math, certain times, and we kind of have that already, because Penn Center, right, for instance, is doing physics here 5 to 9, and then Dawn's doing E&M here on Saturday, and then Zach's doing math here. I'm currently working with the second largest math server. Yeah, I don't like the OG mathematics server. They're a bunch of dicks. I tried like asking to like how I could help them, and they just told me to basically fuck off. And I was like, okay, guys, like, I don't know. They get
which one? The Discord mathematics?
The main Discord mathematics. Yeah, like one of the mods just like I don't know, just got on his high horse.
What does it look
like? It's the Taurus, I think.
It's a Taurus.
Yeah, it's a Taurus.
Oh, okay, yeah. Okay, never mind.
Yeah, I don't like those people. Those people suck.
Yeah, because there's another mathematics one that I'm part of, and that one's the Mandelbrot set, and I talked to those people, and they were like chill. I like gave like 2 lectures.
Oh, nice. Yeah, see, that's what I'm about. Oh, Penn Center says yes, that one, the Mandelbrot set one. He says that one. They are super funny.
Yeah.
Nice.
Yeah, like they were pretty chill, and they were like, "Oh, if you ever wanted to like, do a lecture, let us know." And they were like,
nice,
pretty fun.
Yeah, they're pretty open and stuff.
I didn't interact with the other one because I only found out about the other one like later. But yeah, I guess maybe.
Yeah, well, I guess Penn Center said he's talking to them. So yeah, Penn Center said we were gonna. He has some ideas for 2025, I guess. And we'll loop everyone in on the discussions on that at some point, just to see like what he's doing. But the first step forward, which I really appreciate, is that now there's a global calendar of all the awesome math streamers.
Oh yeah, sorry. Did you say you could link that? Did you link that?
Yeah. So it's on here. Oh, can I share? Oh, yeah. Penn, am I able to like public? Is there a public link I can do for the Google Calendar? Not to edit it, just so that people can view it. Like, is there a public link for it? Do you have to pay money to attend those server lectures? I don't think so. Did anybody have to pay for your lecture that you gave, Ramton?
No, it was free.
Yeah, it was free. Yeah.
Yeah.
Yeah, posted a DM.
I did it.
Yeah.
My goal is like, I do like one, and then if people like it, then they come to me and they pay me separately.
Okay. Yeah, no, it's cool. And if they are interested, they can like learn more from you, right?
Yeah, essentially.
Yeah. Zach says, who's on the VC right now? This is Rampton. I think y'all like just missed each other when Rampton went on like a little bit of a hiatus to like deal with stuff, and now he's back. And then I really started getting involved with like Penn. Yeah, so welcome to meet you guys. Yeah, eat of the two eye pie. His name's Zach. I had him on the podcast here once. He's a math. He used to be a math teacher, I think, and now he's working on his math PhD. So,
nice.
Yeah, he's a really smart guy.
What,
and he does
what area?
I think he's doing his PhD is on how to teach sequences and series, I believe.
Oh. Okay.
Yeah. Yeah, Penn Center and Rampton know each other at least. Yeah. But maybe y'all haven't met.
Yeah.
You haven't met Zach yet. But yeah, there's a whole series of people. I've been trying to learn math on my own, and I'm not in college, so it's very difficult. Yeah, no, there's a bunch. Sorry, what were you gonna say, Rampton?
No, someone was saying like, oh, I was just gonna say, please don't tell me you're doing analysis, and he's doing it now.
Okay, sorry. His master's was on teaching sequences and series. His PhD is on analysis. Yeah.
Analysis is fun, but like, it also makes you question life. But yeah, I heard someone's like, oh, I'm trying to learn math on my own, and I'm not in college. It's very difficult to learn on my own. It's learning math is very difficult, especially if you're learning from a textbook, because the way a textbook is written is like they give you a lot of the fluff of the theory, and you're just like completely lost. So like then you kind of just like, you're like, okay, why am I even learning this? Like, for example, a lot of the theorems, and I heard, like, for example, if you go to Math Olympiad, I was part of Math Olympiad for a few years ago, and then I heard someone recently also say that essentially if you're learning a math topic, the best way, I mean, it's not just math, anything almost. The best way to learn it is to inspire the topic by asking a question.
Like a Socratic.
That, like, yeah. Essentially, it's like, oh, like, let's say I asked you this kind of question. How would you like go about answering it? And a lot of the times, people starts to like turn, and they're like, oh, maybe I'll do this, maybe I do that. And then a lot of the times, if like you got like smart people, not that people are dumb if they don't come with it, but like a lot of the times when you have like a group of smart people, as people start throwing ideas, that almost pretty much just build the foundation of what the theory is. So then when you introduce the theory, people have already like thinking about
they're already familiar to it a little bit. Yeah, it's not just like so super new to them. They're like, oh, we kind of already came up with that. And it's like, actually this is what it is. That's super cool. Nice. Love it. Where one sec. Let me finish this question up real quick for Equal. Okay, are you still here, Equal Throw? Yeah, and Rampton, I can loop you in on the convos when I think Penn Center and Zach want to talk later in the year about. I want to hear what their ideas are for like moving stuff forward. So I can loop you in on the ideas for all the math stuff. Yeah. Okay.
Yeah, as I said, I'll be hopping out like Mondays and maybe Wednesdays a little bit, like depending on how my schedule is. Yeah, I try to like be around for one of the 2 days.
Nice. Yeah, keep coming around, all this good stuff, and then you'll have all the other Twitches for the other guys if you want to. I don't know, as Zach does. So I like Zach fills in our kind of our times that I don't usually stream. Right, like I think Zach, you were streaming Sunday morning or something. Oh, this was at Saturday morning at 9 a.m. I'm like, I am asleep at Saturday morning at 9 a.m. I'm glad he's doing it because like we need someone there. Yeah.
I don't think I would be there.
Yeah. Yeah, and Penn says if you start streaming Ranton, happy to get you in on the calendar. Yeah, exactly. Yeah. We Ranton and I talked about maybe adding like another day where like he does his own stream or something. So maybe, and this is great because we can kind of see like where the where the gaps are. It looks like there's a big gap on Friday. So Friday's got. I usually do the AMA, but I need to get better at getting.
I'm assuming this calendar is already in PST also, because like when I look at the
Yes.
schedule,
Yeah, this is all
of the
Pacific.
ones I think are EST for me.
Yeah, these are all Pacific time. Fridays
Yeah,
are
okay.
Poggies for streaming. What does Poggies mean? It means it's good or it's bad. I don't even know what the terminology is. Yeah. There's that, and then Penn Center. I'll talk to you. I also found like a kid who reached out to me today who's trying to do some really cool stuff. I might bring him into the community and stuff. I gotta vet him out. Oh, Fridays are good for streaming. Okay, so we should stream more on Fridays. Yeah, Fridays like my day off usually, or I'm doing the AMA, which I need to get better at getting guests. Okay. What would you do on Friday night besides watch mass streamers? Yeah. Okay. Let me finish this for you, Equal. Okay. So Equal, we're trying to get this angle here, theta, right? Because that's the final bearing that the plane takes to get back to the airport. All right. And in order to do that, right, I need to get this angle here, this green angle. So what we did is we got the blue side to this triangle, right, using the 1200 sine of 11 degrees, and then we got the light blue side of this by using the 1300 minus the cosine, right? So now we're here. Do you know, Equal, how I would get this angle here? How do I get this angle? It's kind of a good question. Involves some arcs. Oh, good to see you, Nick, too. What's up, Nick? Yeah. Nick in the house. And yes, Penn Center. I love it. Yeah, we're going to do it. We're going to expand, take over the math verse. Let me see. I might have lost Equal. There you go. Here we go. How do you think we would get the green angle? Yeah, there we go. Okay. The way to do this is use arctangent. Yes. Good, man. Good. Yes. Right. So the reason why this is that the tangent of this angle theta here is equal to the opposite over the adjacent. Okay. The opposite is this. That's going to be equal to 1200 sine of 11 degrees. And then the adjacent here is going to be my 1300 minus 1200 cosine of 11 degrees. Okay? And if I want to get theta, right? You guys all said it. It's correct. You have to kind of free this theta from the tangent. Some people are like, oh, just divide by tangent. No. You can't do that. You can't just divide by tangent. It's like tangent of what? You can do what's called taking the arc tangent of both sides. So if we move this over. And what that does is the arc tangent kills off the regular tangent to just give you theta, and then you're left with this. So the arc tangent of this over this is going to be equal to the angle, okay? If we wanted to get that you need a calculator for. So that theta, we can then do, where's my calculator? Okay, cool, there we go. So that's going to be arc tangent of 1200 sine of 11 divided by, and then this is going to be, I love how you call it arctangent. This is why I subscribe to you. We must support the arctan. What do they call it? What do they call it? Like inverse tangent? What do they call it? What's the other word for it? Is pre-calculator? Okay. That's fine then. Well, that would be that. I'm just going to get a number for you. So that's 61.94 degrees. Okay. So if they wanted the heading, right? Remember, that's this angle. Okay. How would I write that in bearing form, right? It's whatever this angle is, right? But this is kind of the weird thing, right? Because like south degrees, this. That's not the answer? Okay. Well, let's see. What is the answer? One sec. There are multiple ways to do it. Like, he probably just is using a different triangle. Yeah, I'm going to check it. One sec. Let me go find it for you. Oh, he has a number. Yeah, okay. Yeah. So, you know, we're close. We're close. Do you see how he has arctangent? He has it flipped. I'll show you why he has it flipped, by the way. Yeah, this is what he has. We'll get the distance and the length. No, I think you just want the bearing. You just want the bearing. So, yeah. So the only difference between our answer and his answer is he does, instead of doing opposite over adjacent, he does adjacent over opposite. And the reason being is he's figuring out this angle. I'll show you the angle he's figuring out. What is it? Okay. He's figuring out this angle as the bearing, which I guess makes sense. Is bearing measured clockwise from north? Really? No, because yeah. Well, whatever. It's like, you know. Oh, okay. Okay, fine. Sure. Okay. See, I was gonna say, I was gonna say east, some degree north, north of east. Oh, okay. Thank you, Jeff. Okay. All right. Does that make sense there? Equal. So I got the green angle. He wants the pink one because he wants it relative to going north. Okay. So in that case, the triangle is just slightly different. So now opposite over adjacent is this side over this side instead of it being this side over this side. It's the same. It's just flipped. So watch. Yeah, because watch. Here, I'm going to show it to you. Okay. So now for this is the opposite, and this is the adjacent. Okay. And so it's this one. So it's this divided by this one, which is this. See how this side is the same as this side? So I could say the pink angle is equal to the arctangent of, and then it's just a flip. That's all it is. We just flip this stuff around. Yeah, do you see that? Yeah, ooh, yeah, it's pretty cool, right? Triangles are super dope.
That's dope.
Like, I like triangles better than circles. Circle theorems like hurt my head. Yeah, okay, cool. So that's where that comes from. Okay? So yeah, that's it. Inscribed angle theorem. It said, what is the plane's bearing from the airport? Oh. Wait, didn't we say what? Wait, isn't that what this is?
No, I think the bearing is like, because the airport.
Oh, they're saying if I'm the airport and I'm looking this way? Like
yeah.
where? Oh. Well, isn't it just the same thing?
Yeah.
Yeah, what?
But no, it would be like pointing south or something like that.
Yeah. Well, let's see. What did this answer have? Like, yeah, okay. So, yeah, exactly. Yeah, Rampton's right. So, instead of north 28 degrees east, it becomes south 28 degrees west. It's the same thing, just in the other direction. Does that make sense? Yeah, they're just saying that, like, if I am here, right, and I'm looking down to the airplane, he's like, okay, I'll explain it to you. It's okay. Yeah, it's okay. All right. Okay, this is the plane. And then this is the airport. So if we're talking about the bearing of the plane to the airport, this is it. This is the bearing. So bearing plane to airport. And then they said this was 28 degrees. Dr. Gold, sir, if I start at the North Pole, go 1 mile south and 1 mile east, then 1 mile north, how far am I from where I started? Stop. No. Yeah, okay. So watch. This is north, right? This is east. So you say north 28 degrees east. Okay? Which means it is 28 degrees east of north, right? See how this is? It's east of north. Yeah. Okay. Yeah, thanks, Pen. That's not an edit link, right? Pen Center? Yeah, okay. I'll send it to Ramton, see if he sees if he can use it. Okay, cool. And then, okay, if we want the bearing from the airport. Okay, nice. Okay. Airport to the plane, okay. That's going to be this angle. Okay. Now, the cool thing is like, yeah, these are parallel lines, right? This is what a transversal is, right? So if I have like two lines like this and they're cut by a transversal, two parallel lines, we assume north is the same north for each one. We're ignore Jeff's snarkiness with like it being a yes, alternate interior angles. Yeah, we are technically not on a linear like plane. Yeah, then this angle is equal to this angle. Does that make sense? Okay. So this one is also going to be 28 degrees. But now this is south and west. So that's going to be south 28 degrees west. Cool? That's actually a pretty fun problem, actually. Wow, that's kind of massive to do this one. You get it now? Nice. Good job, dude. Thank you for thanks for the cool question. Thanks for being patient while we went through it. It's cool. This is a cool one.
Well done.
Here, I'm gonna send you the whole PNG of this. So here it is. So you can look at it later. And then here. And then we're gonna give you points. Nice. Good job, okay. That was cool, man. Good question. Which math subject is this? Algebra 2? I think this is probably pre-calc. Or trig? It's probably trig. Trig and pre-calc.
This is.
What would you say, Rampton? Yeah, I think it's trig.
Yeah, I would say it's more trig than algebra. Because I think it's like the beginning of how you would introduce vectors.
Yeah. Which, I'm surprised. I don't remember going over vectors in, like, my trig classes. Wow, on-screen celebration, 40 bits. Oh, thank you. Thank you, Pen Center. I don't think I have something for bits yet. I need to do that. Where did you get that gold pogger from? The gold kappa. Where'd you get that from? Yeah. Were you the one, Ramton, which was explaining to me where the word cap came from?
Oh, Zach got the baby voice going. Oh my god, Zach. Love it, Zach. Alright, here, let's Cap apparently comes from that character, from that emote, Kappa. Like, it was supposed to be like a look of distrust. And so, like, you'd say something is Cap if it was, yeah, the Kappa guy. Okay, cool, this is cool. Let's pull this question, that's a good one. It's a secret only known to Twitch users.
Man, dude, I want the gold. Where's the gold one, though, dude? How'd you make the gold one? I want the gold one. Instantly got me. It's like, you have my attention. You have a gold one. Oh, I have to teach another student in 17 minutes. Fuck. All right. Let's run through it. Here, Equity, are you still here? You have to get it in a hype train, but it's random. Oh, whose hype train were you in? I think we got it to level 2 or level 3 here. And you only get it for 1 day? Oh, man. That's... Yeah, use that thing as much as you can, dude, please. Yeah. Let me see if Equities. Yeah, that's stupid, right? Sorry for taking so long. Still around. Yeah. Yeah, I gotta use it hard. I was in Pirate Software. Oh, that guy is dope. I do like Pirate Software. Ram, do you know who Pirate Software is?
No.
Yeah, I'll show you. He's like a hacker type dude.
Okay.
Or he used to be a hacker, and he does all these really cool YouTube shorts.
Oh wait, actually, I know him now.
You know this guy, right? Yeah.
Now I saw his voice is also.
Yeah, he needs to like be a voice actor. This guy.
If you want to
No,
notify
I remember the funniest clip I've seen from him was. Oh, he said something. Let me see if I remember. I'll mention it. But it was
okay. Yeah.
About
what is
like
he makes video games? He probably doesn't need to make video games anymore, dude. He can just like make tons of money off all his streams or his shorts here.
Probably.
I just want him to read me bedtime stories. That's too funny. He helped with Heartbound. Oh, okay. I think I know that game.
Heartbound?
Yeah, let me find it. Heartbound. Let me find it.
Oh, it's like.
Oh, okay. Oh, it was on Steam. Oh, it's kind of like not a side scroller, but you know what I'm talking about, like Zelda, like old school Zelda. Or not Zelda, sorry, like Pokemon and stuff. Actually, no, old school Zelda. Old school Zelda used to be like this. Yeah. Oh, that's cool. He did that. Oh, wait, here. Let me let's see.
Who was it, by the way, that was gonna teach? Oh, nice. The calendar.
Yeah.
Oh,
see if that link works for you. Who's gonna teach what?
Who was it that wanted to teach? Oh, there we go. Yes. Now I see it.
Oh, it works. Okay.
Yeah.
Nice.
Yeah. Who was it that was gonna teach linear algebra?
That was Penn Center, I believe, and he did do it. He did it over the summer, I think.
I thought
last year.
he was starting it.
Or are you starting it? Yeah, Zach and Penn, or you're both doing it. Oh, never mind. I take that back. They're both doing it in. Okay, now I remember. Zach did real analysis. Penn Center did complex analysis. I think that's how that went. And now they're tag teaming to do linear algebra in January. Co-teaching.
Oh, okay.
Oh, is this
what are they
co-parenting
teaching now?
Are
they still teaching?
No, Penn Center is going through, I think, learning physics on his own, and Zach, I believe, Zach's in the middle of dissertation writing, so I think he's taking a break from. He was doing a sequences and series class, like an infinite series class.
Oh, okay.
Yeah.
Is Penn Center? Is he also like a?
Penn Center's the department chair at a community college in Canada for the mathematics department.
Oh, okay.
Yeah.
Damn. Okay. Yeah, that was interesting.
Everyone's legit. Everyone's so legit.
All right, yeah. No. I was just asking, like, what's up?
No, I know.
Yeah, Penn Center. If you're learning physics, feel free to hit me up. I mean, maybe you can also like send him my Discord.
Yeah,
in case he wants to.
You should join his streams. Like he's always learning physics, but like struggling because the textbook he uses is like ridiculously difficult.
Yeah, on Discord.
How do I hit Ram up on Discord? He's on Discord. He's one of the yellow. I mean, he's a mod. He's like a super mod on my Discord. It's just Ramton.
Yeah. Yeah, I was gonna actually head out if that's okay.
You're good. I have to teach. I have to teach again in 10 minutes too. You're good.
Yeah. But then Penn Center, I'll definitely. What physics are you learning? I'm just curious now.
I think he's learning mechanics. So right now he's doing. I want to say forces.
Nice.
I feel like Rammy and me will be fasty friends. Yes, good, awesome. Mechanics and I'm crying. It's hard. He's doing like a hard. It's a very difficult. It's like a like upper division mechanics. You know, like when it's just like, what are the forces on the object? It's like cool, and then they're like, you can ignore the mass of the pulley, you can ignore air resistance, you can ignore blah 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 blah. His textbook is like, take all of that into account, and I'm like, oh no, dude.
Yeah. So yeah, I'll definitely hit him up then, and then I get like some of these things I may even need a refresher. on it myself, but like obviously it comes back a lot.
It does
easier
if
to
you've
me.
already done it.
Especially like mechanics was like my thing.
Yeah.
But yeah,
He likes mechanics. Yeah, nice.
yeah,
Yeah,
I definitely like again.
he's streaming. Well, you can see on the calendar. He's doing differential equations. That's what he's also doing. Yeah, he's doing diffie Q. But it looks
Which
like
one is the
physics on Wednesday.
One in this case? Oh, Penn Center actually.
Penn Center, yeah. So he's doing physics on Wednesday. So if you're around Wednesday and want to check him out,
8 p.m. to 12. Okay, yeah.
We start streaming
around.
at the same time. So like I don't mind at all. Like go to his stream and whatnot. Go mess around with physics.
Yeah, maybe I'll just like hop back and forth.
People do that. We do that. Yeah.
Yeah. All right. Okay.
All right.
I'll see you guys probably Wednesday then. Yeah.
Probably Wednesday. Yeah. All good. Nice.
All right.
Okay.
Have a
Good to
good
see you,
night.
Pen. All right. Also, yeah. Okay. Cool. I think that's the last question of the day. I have to go teach another student right now. So let's end the stream off. All right. Thank you everyone for coming to office hours today. Had a really fun time working with you guys. Thanks for all the guests that came by. You know, Ramton, we had Penn Center, we had Zach. I appreciate all you guys. Jeff, thank you for saving my ass on so many questions. And awesome. Yeah, optimal learning. Yes. Thanks for finding us today, Morningstar. Yeah, great. Yeah. Again, if you ever want to, follow more awesome math streamers, here's the list of them right here. I'm going to I'll create a link so that people can click and see the calendar. So I think that should be cool so you can see like when people are streaming and what they're streaming. So I'll do that for my server pretty soon here. Anyways, yeah, our next stream is going to be tomorrow. That's Tuesday. It's going to be an hour later, so that starts at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. So come on by, learn some math, learn some physics, or ask whatever, I teach it all. What we're going to do now is... And 5 p.m. Mountain Time. Jeff's like, don't forget the Mountain Time people. Don't forget the Mountain Time people. All right, let's see. Who's on right now? I think I'm the only one that really streams this late on Monday. Okay. Oh, Don's on. Well, Don's playing video games. Who's doing, like, science? Let's see. But we could go to Butlerian Jihad. I don't know about that. That's a little bit much. I like science. Let's go say hi. I haven't said hi to Balint in a while. They're another really awesome math and science streamer mainly. They're biology people, but it looks like they're doing Microsoft Mondays. High Potential is, but High Potential is sometimes a little strange. The last time, and also I gotta watch next time when Merriweather is streaming, because like the last time I raided into him, he was going over hag maxing, like how to get older women. And I was like, oh no. I rated the wrong stream today because all the kids were like, what is hag maxing? Merriweather was on a tangent. It's okay. Anyways, all right. Awesome. Okay. Cool. Go say hi to Science for me. They're really awesome. Great science people in the Twitch community. Have a wonderful rest of your Monday. Great start to your week, and we will see you guys tomorrow. All right. Peace.